Hello and welcome to Maths 2. As you can see, I've already done a little bit. Really what I wanted to say here was just like this set n is natural numbers and it consists of all numbers, whole numbers, from 1 right the way through, dot dot dot. So as far as the eye can see. And then we have the set z, which is integers. And starts from negative as far as the eye can see, all the way up to through -2, -1, 0, 1, 2, 3, and up and down. And as you can see in this box up here, this is an alternate way of expressing it by saying plus or -1, plus or -2. Often this is actually the way that you get answers in quadratics, I believe. Yeah, well, the quadratic formula is like that, isn't it? Then we have rational numbers, and rational numbers are an expression p over q, and p and q are both integers, basically. So, yeah, that's how that works. Okay, so, but yeah, if you look at this, basically, what's important to realize at this juncture is this set n is inside the set z, and that is inside the set q. So yeah, so you could have a ration. So yeah, so that's basically it. So all of n, all of n is in q, all of z is in q, all of n is in z. So yeah. All right. Let's do a little bit more. I can scroll down the screen. All right. I just may as well scroll out of it. Let's get to the fresh page. All right. So now we need to look at this question. Why is division by 0 undefined? Okay. I think it's actually good if I do line. I don't know. I don't mind writing, but I think when I try to do lines, straight lines doesn't really work that well. So I think I'm going to focus on writing. All right. So what we're going to do is we're going to write the sum 0 times 1 over 0. And then we're going to give it a couple of possible answers. So the answer might be 0. And why might the answer be 0? Well, because, and I believe you can use these 3 dots to mean because. That's what I've always thought it was. And the other way around is therefore. That's the way I like to do it. Okay, because naught, I'll put a dot notation here. 0 times x is 0 for any x. Okay. So yeah, so any number times x is 0 times times any number is 0. So if we do 0 times 10, 0, 0 times 5 is 0 for any x. So we can say, oh, well, that does work actually. But now, the answer could also be 1, couldn't it? Because x times 1 over x equals 1 any x. And that's true, isn't it? Because x, so say 3 times 1/3, or a third of 3 is 1. Or if x is 5, a fifth of 5 is 1 for any x. Yeah. So if we put it in, plug in, we'll see that 0 times 1 over 0 is 1 for any x. But obviously, these two statements not equal. All right. So that's that. Now, how it's okay, I'm going to go a little bit further. Yeah, I'm going to do a couple more things actually. So it's looking so good. I'm really not going to use those lines because it's yeah. All right. So now we'll do. All right, let's try this. All right then. So let's just put some examples here. So we can see that AB times, so A over B times C over D equals AC over BD. So we can see that if we multiply 1 by 2, get 2, multiply B by D, get 22. I'll do one more, why not? Well, actually, don't want to do that. Don't know what that is now. Just put a big bar in there. Alright, so 17 twelfths times 11 seventeenths. Alright, so I'm not going to actually check. I could check these on the calculator, there's not much point. Wow, when you're making these videos, 170 plus 34 plus 24. That's right, first time, wasn't it? Sorry, 170. 70 times 10. No, that's right, second time. 204. 12, 1, 7, yeah. So 187 over 204. Well, that didn't turn out quite as pleasantly as I wanted. Let's try another. I just want to try and get used to doing these things actually. You know, because I'd like to do reasonably hard sums. Let's try this one. So we need 72 more plus 240. '70 squared is 289. So 19. So we need another two lots of 17. 289 plus 34. Do 90 plus 34. It's 334. I'll be right, man. Shouldn't really be doing this. Fucking hell, I can't even remember how to do it now. 33. Three, two, three. Alright. So there's our answer. Good. That didn't take long at all. So we'll call that number 1 here. Okay. Yeah, I can't help but draw these lines across it. I do kind of like it. Alright, so A over B over C over D. Um, mm, hmm. Alright, so I'm going to start with some simple numbers first. Okay. So let's start. Let's scroll down a bit for this. Right. So we've got some rational numbers here. So we'll do a half divided by a quarter. 3/4. May as well. Alright. So okay. So does that look right? What about we do a half divided by half? What about we do 3 divided by 2? Alright. This is 1. So, what I'm going to do actually, I'm going to just have a bit more fun with this. So let's just do loads. Obviously, I'm not going to have the what I had up there before. So let's do 3/4 divided by 7/8. Okay. So 24/12. So will be another good, better way to write it, which is more akin to this. Um, 6/3, I guess. Yeah. All right. So we'll just put that as 6. 24/4. Yeah. Mm. Let's try some more. Just do a few more, may as well, you know. Let's do some squares. In string fractions. Let's just get into it a bit. Um, hmm. So as you can see, there's lots of interesting things going on here. Mm. To do some squares now. What about 1/9 over 1/3? Third. Oh, sorry. Oh, no, wait a minute. Yeah, it is a third. That's pretty interesting, isn't it? It's very fucking interesting, actually. You can see what happens here, then. There's a flip going on. Mm. Okay, so this is the end of Maths 2. We'll be going through more stuff, of course, in Maths 3. So,